Step 1 of Arrow's impossibility. So step 1 of Arrow's impossibility, it says कि if there are three or more agents and you have a welfare function that is Pareto efficient, then if all the agents, you have three or more candidates, sorry, if all the agents, they put a candidate, let's call it B, in the extremal position, either at the very top. So some candidates keep B at the very top, and some candidates keep B at the very bottom. तो extreme positions पे रखते हैं B को, ठीक है? These candidates, or sorry, these agents, three, and there are M agents. So the welfare function should also keep B either at the very top, and if not at the very top, then at the very bottom. ठीक है? So that's what we want to prove in step 1. Okay, if B is placed at the very top by all the agents, then it should be at the top. If it's placed at the very bottom by all the agents, then it should be at the very bottom. But if it's in the extreme positions, okay, either it's at the very top or at the very bottom for each of these agents, so it should also be either at the very top or at the very bottom in the welfare ordering, in the final social welfare ordering. Okay? So this is what we want to prove. Now, if this is not true, and which we were looking at as a proof by contradiction. Okay, this is not true. That means B would exist somewhere in the middle. So B would not be at the bottom and it would not be at the top. So it would be somewhere in the middle. And by middle, meaning okay, there is something above B, and let's call it A, and then there is something below B, let's call it C. Because there are at least three candidates. So there has to be at least two more other than B. So let's put one above B and one below B, so that we find a contradiction कि भाई ठीक है, maybe our claim is not true, and contradicting what that claim would be B is not either at the very bottom or at the very top. ठीक है? So looking at this, we can say that in this given this preference profile of voters, of all the agents, A is above B and B is above C. Right? Okay. Now that means if A and C exist in the final ordering, they would also exist in the agents preferences. कि agents की preferences के अंदर भी A और C मौजूद होगा. And let's say कि कहीं arbitrarily मौजूद है. कहीं भी arbitrarily, कहीं C A C की कोई भी डाल दी मैंने बीच में. And this whole preference profile is called this. Now I want to change this preference profile slightly to make this preference profile slightly, or the change is reflected by this red lines. कि क्या change होगा? This is the current preference profile that you're looking at, and this new preference profile is the exact same as this, except where C was below A, I move it above A, just right above A. See? So C was above A in this case, C was above A in this case, C is below A in this case, so I'll just take C and put it above A. C is below A, so I'll put it right above A. And note, if B is in the extremal position, if it's at the very top, we are not going to disturb B or the relative position of B and C. If C was below B, it's still below B. So if there was nothing between B and A, we just push A down and C above. and same thing goes here. So if B was at the very bottom, C was above B, and moving C above would not have any effect. And in many of the cases where C is already above, we are not even changing this preference. So let's say C was above in this case. So having moved C above A in all of these voter profiles, we get this new preference profile. Okay? And in this new preference profile, C is above A in for all the agents. That means that by Pareto efficiency, C should also be above A in our final ordering. So by PE, C should be above A for this preference profile, the new one, in the final ordering. See? So we should move C here. Okay, that's fine. How about the relative order of A and B in the new preference profile? The relative order of A and B has not changed. So if B was above A, it's still above A. And if B was below A, still below A. That means the relative order of B and A has not changed. Okay. So that means, okay, if the relative order of B and A has not changed, that means this holds true for the new preference profile as well. And let me write this down here. Okay, A is above B in the new preference profile given to this welfare function that's Pareto efficient. Okay. How about C? The same exact logic goes for C. Okay, the relative ordering of B and C has not changed. So if B was at the very top, C, by moving C here, it does not change the relative ordering of C in this new profile as compared to this. So that means K, C is still below B because we got that from here. Okay. Now, when we combine these two, and say that by transitivity, if A is above B and sorry, B is above C, I made a mistake. So B is above C, then A should be above C. A should be above C in the new preference profile. But we know by Pareto efficiency, we had already concluded that C is above A. And now these two are in contradiction. And that proves our point by saying that our assumption that B is not in the extremal position if every agent puts B in the extreme position either at the very top or at the very bottom, that assumption was incorrect. And B must be in the extremal position for any welfare function that's Pareto efficient, where there are more than 3 or more candidates and all the agents are voting for B at the very top or at the very bottom. Okay? So that's step number 1 of the Arrow's impossibility theorem proof.